Alright, we have something here that I think we've done with our calculators, at least one or two of my classes have, and it is inequalities. So we've graphed lines, but now we're going to graph lines that have a restriction, and you're going to see they form what we call a half plane when we graph them. So a linear inequality in two variables can be written in the form, well, their standard form, ax plus by is less than c, except it has a less than, and ax plus by is less than or equal to c. Alright, we also have ax plus by is greater than or equal to, or ax plus by is greater than c, where a and b are constants, a and b are both not zero, and the solution for the inequality in two variables one or more ordered pairs that make up the inequality true. So, take out of that is we're taking the standard form and doing something a little different with it. Alright, some students who recite at a recital perform 3-minute pieces, and some perform 5-minute pieces. The total time is 30 minutes long, so there we go. Some of them, students that are X, are 3-minute pieces. Some of them are 5-minute pieces, and they have to be under 30 minutes. Now, we could graph by intercepts, but something like this is probably a little easier to see if we put it in slope-intercept, just because of this inequality, right? So if I subtract 3x, right, minus 3x, our goal is to solve for y. I got 5y is less than or equal to negative 3x plus 30. Almost there. Divide by 5, and now we solve for y. Y is less than or equal to negative 3/5 x plus 6. Not too bad. I know we cross at 6. My slope is negative 3/5. As long as these scales are the same, which they look to be, I can just go down 1, 2, 3, and over 1, 2, 3, 4, 5 right here, and I can graph this line. Now, we look for an equal sign. It is. There's equal, so it does touch this line, but it says y is less than this line. So y being up and down, I'm going to go under the line, and I'm going to shade everything. Everything over here is true. Look, if I pick 0, 0, and plug it in, 0 is less than or equal to, well, this is 0, 6, which is true. I plug a 0, 0 in for x, so I know this is true where I shaded it. Alright? Now, if you look at this, we can replace the inequality with an equal sign, right? And this is our boundary line, which I already did, right? And we got, what? Y equals negative 3/5 x plus 6, right? And let's graph that again. We went through here, and I think it was out here. Graph that one more time. Alright. The part of the coordinate plane containing the solution set may be included in the line is also called a half plane. Since the inequality is greater than, was it greater than? Did say greater than. Oh, you know what I did? I graphed less than. So let's go ahead and graph greater than. This says must be at least. So let's graph greater than just because. What if I said y is greater than or equal to negative 3/5 x plus 6? Now, this is a little bit off the beaten path. But greater than, if I put my pencil on this line, would be every y above this line. So it would be everything on this part. Alright. Notice that these are half planes. When I graph less than, by mistake, but I graphed it anyway. And when I graph greater than, it went up. Let's keep going. Let's see if we can get a little bit more. Alright. 324. Alright. So, we said, let's put the greater than. Y is greater than or equal to negative 3/5 x plus 6. Y is greater than or equal to negative 3/5 x plus 6. If I pick a point like 0, 0 that's below this line, 0, right? It's below this line. Let's see if it's true. 3 times 0 plus 5 times 0 is less than, that is false, right? 0 is not greater than 30, right? So this would be false. If I pick any point and plug it into, they had us use that original one, didn't they? 3x plus 5y is greater than or equal to 30. What if I pick 8, 8? Above the line. Above the line. 3 times 8, 5 times 8 is greater than 30. What is that? 24 plus 40. 64 is greater than 30. So we can test it with a point, which would be true. Alright. discuss how this graph would change if it were greater than instead of greater than equal to. This means the line wouldn't be true. Line wouldn't be true. Cool? There is a graphing calculator portion here, and we're going to have to skip that graphing calculator portion. Alright? I'm going to come here to 325. Now let's try to get through this 325 page. Alright, hopefully it'll work out okay. So they give us an equation. That's 14 plus 2y is less than or equal to negative x. We're going to solve for y. Right, we would do that by adding 14 to this side, right? And then dividing by 2, right? Which gives me 1/2 x, negative 1/2 x, plus 7. So if we graph the boundary, right? The inequality symbol uses the less than. It's going to be represented with a dashed line, which means it's not actually going to be the line. And to show points on the line are not part of the solution. So when we have a dashed line, when we use these, right, and when we have less than or equal to or greater than equal, we use a solid line. Let's graph this guy. Looks like it's got a y-intercept of 7. It's got a negative 1/2, so down 1 over 2. I'll do another dot, now 1 over 2. Can use a dashed line to go through this, right? Dashed line to go through this, right? To shade the appropriate part of the graph. The symbol is less than, so shade below the boundary line. So let's graph it here too. We crossed here, here, dashed line, and less than means it's everything down here. We'll test to see if 0, 0 is true in the original equation, or in any equation really. So I could say negative 14 plus 2y is less than negative x. If I plug in 0, 0, this is below the line, and it should be true because we shaded there. And I could say negative 14 plus 2 times 0 is less than negative 0. Well, negative 14 is less than 0, so that's true, and it should be because it's in the shaded region. It should make the equation true. 8, 8 is above. Notice how they're picking the same number. But here we go. This would be 16, this would be 2, is less than negative 8. That is not true, so this would be false. And honestly, obviously, 8, 8 is up here in the non-shaded region. Let's see if there's any more. There is. Let's get all this done. It shouldn't take us too long. Is 6, 4 part of the solution? I don't know. Let's go look on the graph. 6, 4 is right there. It's not part of the solution. No. Out of shaded area. So we're going to do 2 more here and stop. Alright. Not too bad. I'm going to solve for y. Ooh, there's a trick in here that I need to talk to you about. Minus 3 minus 3. We got negative y. Alright. Is less than negative 5x minus 3. Now, I'll show you this again. I showed you in class once. If I divide by negative 1, we got y. Remember to flip the sign. Is greater than 5x plus 3. Alright? So if I got this going, I'm going to cross at 3. Probably right about there. I've got a slope of 5, so from 3 to 8, and then over 1, which is right about there. I got a graph that looks similar to that. You know what I should have used? I should have used a dashed line because there is, I'm just going to make a dash like that. Right? There's no equal sign. And then I put my hand on it, I shade up. So it's everything over here above the line. That slant makes it look a little weird, but that's what it is. I'm going to go right here. We're going to subtract 10x, and I got 8y is less than negative 10x plus 64, and we divide by 8. We don't have to switch the sign because we didn't divide by a negative, and I get negative 5/4 x plus 8. 8's right here. I go down 5, right 4. What was that? 2, 4, 5. Right 4, right there. I should have used a dash line. I'm going to use it on this side. Should have used it on this side too. Alright, dash line. It says less than, so we shade down again. And for right now, I am going to pause. That's going to be it. we've done the first 4 pages, I think. Maybe it's just 3, but I think we've done 4. And that should be most of what we do. It's been 10 minutes, so I'm going to pause this and let it save.